All right, so in this example, we're going to go ahead and start to solve a rational equation. And I've kind of listed right here our steps in doing that, and all the subsequent examples to follow we'll kind of go through these steps right here. So in order to determine what is x right here, where we have 1 over 3x minus 3 over 4x equals 1/3, what value of x will satisfy this? What value of x will make this equal to 1/3? Okay, so there's a few things that we want to do here first, and that is to first find the domain of the variable. And we learned that from the first example. And basically, the domain, I'll just do it over here, was, we know that it was going to be x, and then x is a real value. Such that x is not equal to 0. Okay, and we kind of want to do this first because when we actually get our answer, and we'll see in later examples that some of the answers that we get are actually ones that say x cannot be that, and so those are going to be called extraneous roots, and so we're going to discard those, and we just want to do that first, just so that that is in the forefront of our minds, and we don't say that that's a solution and getting the incorrect answer there. Okay, so now what we want to do is just like anything else, right? Like, we don't like those fractions, so we want to get rid of fractions now. Okay, and that's why we do the second step, is multiply each step by the of the equation by the lowest common denominator. Okay, and the lowest common denominator between 3, 4, and 3 is 12, and then you would just include your x right there because each of these have an x. So that means in order to make all three common, this would need an x as well. Okay, so let's multiply everything by 12x. So that's what I'm going to do over here now. So I'm going to do it separately each time. So 12 times 1 over 3x minus 12 times 3 over 4x is equal to 12 times 1 over 3. Okay, so I'm multiplying everything, multiply each side of the equation by the lowest common denominator. That's the same thing, same multiplying everything by 12, okay? And so if you see this here, 12x, got about the x right there. There we go. 3x, well, 3 goes into 12 4 times, and the x's cancel. So 4 times 1 is just 4. 4 goes into 12 3 times, and the x's cancel out. So -3, see that right there, that little negative sign? -3 times 3 is a -9. And then 3 goes into 12 4 times, so it's 4x times 1. That's just 4x. Okay, so 4 minus 9, -5, is equal to 4x. And then we just divide both sides by 4, and we get x equals -5 over 4. Okay, so which means that, you see right here, our domain was going to be x is going to be a real number, right? A real value. Well, yes, it is. That's a real value, and x is not equal to 0, and that is not 0 right there. So we're good right there. Good, so we've done step 1, 2, and we've done step 3. Now, I know that this part can get kind of tedious, it can get kind of boring and all that kind of stuff, but it is a good idea to check it just to make sure that this really is a solution. And one way that you can do that, as it says right here, is check the remaining proposed solutions in the original equation. Well, we only have one solution, but basically you want to plug this in, right? Like, take your -4/5 force and plug it back in here, and that can get kind of hairy and all that. So what I'm going to do to kind of check my answer here is I'm just going to use Desmos, and so I just went to desmos.com, and I kind of already inputted these two here. Don't mind all these examples because these are from next examples coming up. But if I were to graph, check this out right here. If I were to graph the left side, y equals 1 over 3x minus 3 over 4x, so graph the left side, and then graph the right side, y equals 1/3, because basically what this means is if I were to graph both sides of this equation and where they intersect, that is the solution. And that's what the equation sign means. When are they equivalent? And that's why if you graph it, that's a visual of that. And so if I graph both of them, if you just look right here, the graph is looking like this, and see how they intersect right there? Right there at negative 1.25.333. Remember, our solution here was negative 5/4. And negative 5/4 is negative 1.25. See this right here? Negative 1.25. So when x is negative 1.25, what is our y value? 0.333, or 1/3, right? When is this all equal to 1/3? Oh, when x is negative 1.25, or in other words, negative 5/4. So this just verified right now by graphing. Okay, this intersection right here verifies that our solution is correct. Cool beans.